Off camera, I've gone ahead and assembled the sensor module printed circuit boards to the extent that I've added the needed components to them, the through-hole components that have to be added to them before they can be assembled into the completed sensor module. And I didn't show that because it uses techniques that we've already discussed, including soldering on the USB jacks and soldering on through-hole components. In this case, these are small resistors. So what I want to do is just take you through each of these and review which resistors and USB jacks, or which ones have resistors and USB jacks, and how many of these you're going to need. So we'll start with this one. This is the board for the arm or the femur. It'll be identical for the arm and the femur. And you'll need two of these, one for the arm, one for the femur. And as you can see, these have a USB jack, and these also have 4 resistors. Now, in this case, there are 2. These are R1 and R2. Those are going to be 6.8 kiloohms. And then R3 and R4, the other 2, are 2.7 kiloohms. Next, we have the board for the leg or forearm. So one of these is going to go on the tibia, the other is going to go on the radius of the forearm. Now, this PCB is smaller, and in fact, it's the same PCB that's used for the hand or the foot, and also for the torso. So hand, foot, arm, forearm, leg, and torso all use the same PCB. They're just populated differently. In this case, we have a USB jack, and we have 2 resistors, and these are both 2.7K resistors. It's 2.7 kiloohms. So you'll need 2 of those as well. Next, we have the ones for the hand or the foot, and the difference here is that it does not have a USB jack. It's not needed, since this is at the end of the bus for those 2 limbs, for the upper limb or lower limb. And the resistors are a bit higher value. These are 4.7K resistors. So we'll need 2 of those, one for the hand and one for the foot. And then lastly, we have this one. This is for the torso module. And again, it's identical to the others, except that, again, no USB jack, not needed. And we have 2 resistors, in this case, at 2.7K. So you only need 1 of these. So the next step in assembling the sensor modules will be to add to each of the PCBs one of these right angle headers to hold the LED modules, the assembled LED modules. Now, even if you're not planning at this point to assemble and use LED modules, it's a good idea to go ahead and add the headers, because it doesn't take that much longer, and it makes it much easier to add the LED modules later if you want to. Okay. Now, what I've done to prepare is taken one of these right angle headers, broken it off into a group of 4, and then I take the long end and I slip it through these 4 holes that are marked VN, SDA, SCL, and GND. And you can see there's 2 sets of them, and they're connected across like that. And you want to insert this into the ones that are all the way on the edge. And I held some tension on that to keep it flush all the way in. And then I came in with my nippers, my flush cutters, and I cut each of these pins as close to the PCB as I can, so that when that's done, I'll have a setup where the pins are barely poking through the underside of the printed circuit board. And that's necessary because I don't want that area of the PCB to have any rough edges. So by having them flush like that, I can add some solder and form it into a smooth dome, so that there won't be anything to potentially tear or wear through the wires from the USB cables. That's probably pretty unlikely to happen. There's not a whole lot of way that those cables could move, but nevertheless, I think it's a good practice here. So I'm just going to hold that in and go ahead and just tape it down. just to add a little bit of tension. And then, since I don't really have access to the pin to heat it, I'm going to add some flux, and that will help me get this soldered properly. Now I'm just going to get one of them soldered on the end, and you'll notice that nice smooth dome of solder. And I can give it a bit more heat to make sure that it's all the way in there. Nice and smooth. Now, what I want to do before I do the others is to check and make sure that that is about at a right angle. And you'll notice it's canted forward a little bit. That's easy to fix. All I have to do is hold this. Now, this part's going to be pretty hot, but these other pins won't be. So if I just hold that like so, put a little bit of pressure on those pins, and remelt that, you'll see that it shifts and becomes a right angle again. So now it's pretty much at a right angle. So now I can use that one I've already done to hold it still, and I can finish out with the others. So that should do it. Now I have nice smooth domes of solder there. They're not going to really cause any problems. So I've just demonstrated this on one of the PCBs for the arm of the femur, but you're going to want to do this to all the rest of them as well, again using the outer set of holes. Right, same procedure for all 7 or sensor module PCBs. I want to talk about preparing the cut ends of the cable to mount them to the boards. So what I have here is a USB cable. On one end is the USB mini B plug. On the other end, I've cut it off. So this came from a US mini B to USB A cable, and I just cut it off at the appropriate length. This one is for the arm. I think it's about 82 to 85 centimeters, around there. So this is probably the most difficult, and I guess a good word would be fiddly, part of assembling the smart skeleton, is getting these wires attached to the modules. So what you want to start with is, measure out about 20 millimeters or so of about 3/4 of an inch of wire, and then I just take a razor blade and lightly score it in a circle around, and then pull the PVC jacket off of the cable. Okay. Now what you see here is this is a shielded cable, which is good, but all this shielding that we've cut off has to be removed. You don't want to leave any of these shielding cables present, because they'll definitely get stuck in there and cause shorts. The only one that you want to preserve is this one that's in copper, right? And this one that's in copper here. So these monoprice cables that I spec'd in the build list come with this braided jacket, and then you have this one piece of bare copper that's coming off of that. So what I'm going to do is take clippers and cut all of this shielding cable off, leaving behind that. I'm also going to peel away this shielding foil and cut it away. And when I'm done with that, I will bring it back in and show you how it looks. So as you can see, I've removed all the shielding foil and cable. All that's left is little stubs of it. I got it down as close as I could with my clippers. Now I'm going to strip about, I guess, 5 millimeters of insulation off the ends of these. That's closer to 3 or 4. About 3/16 of an inch, I guess, of insulation off the ends of each of these wires. And when I'm done with that, I'll bring it back in and show you how that looks. So as you can see, I've stripped a bit of insulation off the ends of each of the colored wires. I've also twisted all the conductors inside together to keep them from scattering, as well as twisted the conductors in this bare braided copper cable. So now I'm going to put a bit of flux on the end of each one. And what I want to do is tin these together with some solder, and that'll keep them from unraveling while they're being fixed in the holes the holes in the PCB where they belong. And this is really easy to do. You just take the solder on one side and the iron on the other and just kind of rub it up against the wire. I'll lift that one up so I don't burn the paper. Okay, so the next thing to do will be to attach a separate conductor to this braided cable. So I'm going to do that off camera and then show you what I've done. So I've prepared a little piece of 30 gauge wire here. That's plenty big enough just to carry a shielding conductor. I like this silicone sheathed wire. It's very, very flexible. And I just put a little loop in that copper conductor and twisted it together a little bit. And so now I'm going to attach this to that, just twist them together and then solder it. I need both my hands to do that, and I don't have a good way to mount it under the camera, so I'm going to do that off camera and come back and show you how it looks. So I've clipped the excess on that, and I've prepared a little piece of heat shrink tubing. It's the smallest heat shrink I had. It could probably be a bit smaller, but this will work. So I'm going to go ahead and just slip the heat shrink on there. And then I'm going to apply some heat and get it fixed on there and then come back and show you how it looks. So here the end of the cable is now prepared. I've essentially added a separate insulated conductor by attaching a bit more wire to this. And this is going to go onto the shielding conductor on the board. I'm not going to strip this one yet because I want a better view, a better sense of how much length I'm going to need. And this is so flexible, it's easy to do that one after the others are already attached. So let me get this set up so I can show you how I solder these into the board. So I've got it held in these helping hands now, and I want to try to at least get one of them right away to start with, and the one that's most accessible is VN here on the edge. That one has the red wire going into it. Okay. All right. Now before I do the others, I want to confirm that I'm going underneath and having a look and making sure that the wire is seated all the way in up to the edge of the insulation. Like I said, this part's the most fiddly. So it looks like and what you can do now that I have one seated is I can actually grab the wire and pull it in to make sure that it's seated. So now I can do the ground one. If I wasn't filming this, I would be using a much more advantageous angle. Okay, so now it looks like SDA is well placed. So ground is the black one, VN is the red, SDA is the green. So I'm going to grab that and pull it all the way in. Okay, it's a bit too much solder on that one, but it'll work. Okay, there's that one. Okay, so that's got them all. Let's have a look at them. Now once you get these soldered on, you want to be careful with them because these wires inside the USB cable are not designed to kind of hang out on their own. They're designed to be part of that larger wrapped cable. And so they can be a little bit delicate. So you don't want to bend this back and forth any more than you can possibly help. Because if it breaks, you have to do all this all over again. Right, so I've clipped the extra leads there. And then the last bit is to prepare the ground cable to go in. So let me do that off camera and come back when I'm ready to solder it. So the shielding conductor is ready. It's fed through the hole there. I just stripped a little bit off, tinned it with some solder, and now it's ready to be permanently attached. So there we go. And now this one is ready for the next step, which will be to attach the other boards that go on this, the arm board. So the arm and femur, we have a multiplexer board, and we have, of course, the orientation sensor. So that'll be our next step. And whenever, as we do those steps, again, we want to be sure to bend those wires to the minimal amount, as little as possible. Next, I want to attach the accessory boards to the printed circuit boards for each of the sensor modules. And in the case of the arm and femur, this will include both the serial switch and, of course, the orientation sensor. But you want to do the serial switch first because it will be basically impossible to do after the other one is attached. So on the underside of this board, you can see a marker for VN-TCA9548. Of course, that is the serial I2C serial switchboard. And what I've done to prepare is I've gone ahead and kind of flattened and arranged the wires for the USB cable. And now I can go ahead and just insert this board all the way through. I'm going to push it in till it's completely flush, right? Till the pins are in as far as they can go. So I'm going to go ahead and tape this down and solder this off camera because it's just through-hole soldering, the same as we've done before. All right, so I finished soldering the serial switchboard all the way flush to the underside of this arm or femur board, and you can see I've also trimmed the excess pin length, so it's just above the solder fillet. That's plenty close enough. So now I'm going to prepare the orientation sensor board to be mounted, and I'll do that again off camera and come back and show you it when I'm finished setting it up. Just real quick to show you how this goes in here. You can see, just as with the underside, there's an indicator that says B&O 055 board VN, and so this is where this one's going to mount, just there. Now I've prepared the orientation sensor board to be mounted. You can see I've got 3 of the 3D printed spacers. Also notice I'm supporting the USB cables. I do this, I don't want to put any unnecessary strain on those connections until I get it in the case. But on this side, it's going to be relatively easy. All I have to do is solder underneath there. I have access to those pins. On this side, it's going to be a little bit harder. So what I'm going to do is go ahead and solder these 4 pins, and then I'm going to sneak in and solder one of these, and then I'll have 3, or at least 3 points of connection forming a triangle, so I know that the board will maintain the correct distance without the spacers. So then I can remove the spacers and show you how you can solder into that tight space. Okay, so I've got the other side soldered, and as you may be able to tell I've soldered one of these pins. I've got it propped up at an angle so that the camera can see it, but also that I can see what I'm doing. And so what I'm going to do is just go straight in with the iron and then come in from the side with the solder. So basically I'm just using the tip of the iron to heat and then bringing in the solder from the side. Now this one's behind that other one, so it's going to be the hardest. There we go. I'm going to do this one on the end first. And for this one, I'm going to have to switch hands and solder left-handed, which is going to look scary. Okay. So that's got that side. Now, you'll notice that there are excess pin length hanging down underneath the board, but it's not a problem because it's not contacting anything, and there's no way to trim them anyway. Okay, so that's got that one mounted. Now, for the other boards, the smaller boards, this one is set up to be the foot or the hand. It's much easier because when you put the sensor in with the spacers, right? I'm not going to put the spacers in, but there's plenty of room to clip them. You'll have free access to the underside, so it's much easier to solder. Just remember that this one's set up to be the foot or the hand. Just remember to use the sensor boards for those where you have bridged that solder jumper on the underside to change the address, the I2C address for the hand and the foot. The last step in assembling the sensor modules is to attach the LED module if you are going to use them. So I have a separate video showing how to assemble these. It involves more advanced surface mount soldering techniques. But one of the things you have to do after you assemble these is essentially program their I2C address by bridging a solder jumper between a center pad and one of two side pads, either to set it to a 1 or a 0. So in this case, you can see the bit A1 is set to 1 and bit A0 is set to 0, and so that finishes out an 8-bit I2C address. And as I describe in the text of the paper, this is the code for arm and fever modules, a 1 and a 0. So this one is appropriate then to place on this module, which is for an arm or a femur. And it's really easy to do since we've already put the header in. It simply slides over like that, and we want to solder on this side so that the LED module ends up being pretty much at a right angle to the other boards. So I'm going to do that off camera and then just come back and show you how it looks when I'm done. So now we can see the LED module is soldered in place at all 4 positions, and it's roughly at a right angle. It doesn't have to be precisely at a right angle. That'll work. Okay, so now this module is prepared and ready to be placed in its case.